This video is to serve as a review, and I'll be going over questions from the practice objective check for PR1 through PR7. Now note that these problems are for personal review or study purposes only. They're not graded, so don't attach work to these questions unless you're practicing that function. And I suggest you do practice that function at some point. So PR1, this objective says, graph a quadratic based on the vertex, zeros, Y-intercept, domain, range, and stretch or compression. We are told to graph the parabola, don't place any dots, then fill in the blanks about the vertex, any intercepts, the domain, and range. Enter intercepts as ordered pairs, aka points. We have the function y equals x squared minus 8x plus 15. First, I want to identify a, b, and c for this quadratic. And this is in standard form already, so a equals 1, b equals negative 8, and c equals 15. Now, we can take those values of a, b, and c and evaluate those in the formula for the vertex. H equals negative b divided by 2a. And since b is negative 8, that will be negative 8 divided by 2 times 1. So that h for our vertex will be positive 8 divided by 2, or 4. Now, to find the k value for our vertex, I'm going to take that value of 4 and evaluate that into our function. So I'm going to find f of 4. That will be parentheses 4 parentheses squared minus 8 parentheses 4 close parentheses plus 15. Now 4 squared is 16, so this will be 16 minus 32 plus 15. It should be negative 1. Yes, that is equal to negative 1. So our vertex is the point 4, negative 1. I label that as v parentheses 4 comma negative 1 close parentheses to indicate the vertex. I'm going to go down to my blanks and write the point 4, negative 1 in parentheses. My vertex. And I'm also going to plot that point on my grid. So I'm going to go 4 on the x-axis, 4 to the right, and down 1 in the y direction. So at the point 4, negative 1, I have my vertex. Now, my a value was 1 from identifying a, b, and c, which means that this graph, because a is positive, it opens up. And so I can put a point here at, starting at 4, negative 1, I'll go up 1 to the right 1, that is at 5, 0. And up 1 to the left 1, that will be 3, 0. Now, when you're doing the actual objective check, you want to click on the vertex. You want to choose that, and then choose one point. Either one of those 2 points will do. And then it will fill in the rest because quadratics are symmetric. Now, I notice those 2 points that I just plotted on my written graph are 3, 0, and 5, 0. Those are actually the X-intercepts. So I'm going to go down to this box and type parentheses 3, 0, close parentheses, comma, parentheses 5, 0, parentheses. That's your X-intercept. Now, my vertex also tells me what the axis of symmetry is. The equation for the axis of symmetry is x equals 4, because my vertex passes through the x value of 4. The x value of my vertex is 4. So, equation of the axis of symmetry is x equals 4. The domain of every quadratic will be minus infinity to infinity. And of course, we never include the infinities. So parentheses, negative infinity, comma, infinity, close parentheses. Now, the range is given from the vertex. Because we have a minimum here, our range is the lowest point here, negative 1, and increasing on up. So my range would be bracket negative 1, comma, infinity, close parentheses. If my graph opened down, it would be from minus infinity to whatever that highest point is. So that would vary depending on what the a value is. Now for the y-intercept, the last thing I need to do is evaluate my function for f of 0. So that's finding my y-intercept. All the other work I had up here was for the vertex. So f of 0 would mean we have 0 squared minus 8 times 0 plus 15, which means our y-intercept is positive 15. So the point 0, comma 15 for our y-intercept. I'm going to put that in my box. 0, 15 in parentheses. Right, now there's a place to add work for this question. So as you can see, there is some work that goes into these, to this particular question. All right, now for PR2, the question is apply the equation of a quadratic to optimize a quantity and find when quantities attain specified amounts. So this question says write a function modeling the situation and then solve algebraically, not graphically, to determine or to complete the statements. Now the height of an object launched upward can be modeled by the function h of t equals negative 4.9 t squared plus v0 t plus h0, where v0 is the velocity at which it was launched and h0 is the initial height in meters. And the scenario is NASA launches a rocket from a height of 150 meters with a launch speed of 187 meters per second. So the equation that I can write here will be h of t, height of the rocket, and that'll be negative 4.9 t squared. Now, plus v0. Well, my initial velocity is 187, so this would be plus 187 t plus h0, which is the initial height of 150 meters, so plus 150. Now, the question asks for, the thing we're trying to fill out is the rocket reaches its maximum height of blank meters, and the maximum occurs blank seconds after it is launched. So because these both relate to the maximum, and this function does have a maximum because the a value is negative, it opens down, because this function does have a maximum, that's going to be our vertex. So I'm going to take my a, b, and c values. A is negative 4.9, b is equal to 187, and c is equal to 150. I'm going to find my vertex, so I'll use x equals negative b divided by 2a. b is 187, so this will be negative 187 divided by 2 times negative 4.9. So that the x value of my vertex is, once I get a calculator out, negative 187 divided by 2, parentheses, negative 4.9. Okay, that would be at, I'm going to have to round 2 decimal places. This will be positive 19.08. 19.08. Now the x-coordinate in this context is actually the time, because the function is h of t equals. All right, so the x-coordinate, or the t-coordinate really, is going to be 19.08 seconds. Now that is when the maximum occurs, so I'm going to put that in my second blank. The maximum occurs 19.08 seconds after it is launched. Now to find the maximum height, we'll take 19.08 and evaluate that in our function that we had. So that's h of 19.08, which will be negative 4.9, parentheses, 19.08, close parentheses squared, plus 187, parentheses, 19.08, plus 150. Now, of course, use a calculator to evaluate that. Right, and that is a value of 1934.132, so 0.13, and that is height, so this will be in meters. All right, so that is our vertex. And to answer that question, the rocket reaches its maximum height of how many meters? Of 1934.13 meters. And of course, you can also see that we had some work that was necessary here. So there is, in fact, an add work box to put that work. Right, next, we have PR3, classify a polynomial and determine end behavior. And so question 3 says, describe the long-run behavior of f of x equals negative x to the fourth. And it says, as x approaches negative infinity, f of x approaches blank, and as x approaches infinity, f of x approaches blank. Now, we've kind of talked about this in class, the infinity notation, but really, the choices come down to, does the function fall left or rise left? Does the function fall right or rise right? I want to draw this little chart that I put in our notes. So there are 4 possible options here. We either have, talking about the degree, an odd degree or an even degree. And for our leading coefficient, which I'm going to write as LC, we either have one that is positive or one that is negative. So our choices here are a function that is an odd positive, an odd degree, and a positive leading coefficient, an even positive, which is an even degree and a positive leading coefficient, odd negative, which is an odd degree with a negative leading coefficient, and an even negative, even degree but with a negative leading coefficient. So I'm going to draw what the arrows to represent these. So an odd positive will fall to the left and rise to the right. An odd negative will rise to the left and fall to the right. An odd even will rise to the left and rise to the right. And an even negative will fall to the left, fall to the right. So this particular function is negative x to the fourth. That is an even degree, x to the fourth, and a negative leading coefficient, the negative 1 there. So an even negative will fall to the left and fall to the right. So I'm going to choose the box that says on the drop down, negative infinity, which means falls left. And the second box, I will choose negative infinity, which means that it falls right. That's all there really is to end behavior. Now we'll get to combine that with some other things in a minute, but that's PR3, classify a polynomial and determine end behavior. All right, now PR4 says divide polynomials using synthetic and long division. Now, with this question, we're told divide p of x by q of x. If there's a remainder, express it in the form r divided by q of x. And we're told that p of x equals x cubed minus 17x plus 28, and q of x equals x plus 5. So what this means we're doing is we're dividing x cubed minus 17x plus 28 divided by x plus 5. Again, we have these two quantities, polynomials we're dividing. So because x plus 5 is in the right form for synthetic division, I'm going to do a synthetic division with x equals negative 5. Because negative 5 is the value that would make x plus 5 0. Now, you always want to look for missing terms. I'm going to write these coefficients down as 1x cubed, so 1's I'm going to write, 0x squared, because there is no x squared, minus 17x, and plus 28. So my coefficients that I've written down are 1, 0, negative 17, and 28. As always, we will bring down the very first one of these, going from left to right. Bring down the 1, so then we take negative 5 by each one of these. Negative 5 times 1 is negative 5, so I'm going to write that under the 0. Add going down, 0 plus negative 5 is negative 5. Negative 5 multiplied by negative 5 is positive 25. Take negative 17 plus 25, that'll be positive 8. Negative 5 times 8 is negative 40. And then finally, 28 minus 40 is negative 12. So my answer is, I started out with an x cubed, so my answer is going to be an x squared. It'd be x squared minus 5x. These are coming from the values I got in my table. Negative 5x plus 8 minus 12 divided by x plus 5, because that was my divisor. And again, there's work to be added with that. You always want to watch your positives and negatives, and definitely look out for missing terms if there are any. All right, PR5, determine zeros and multiplicities. Depends on solving quadratics by factoring and polynomial division objectives. So in question 5, we're told to find all real zeros of the function f of x equals 16x cubed minus 64x squared minus 77x minus 15, given that x minus 5 is a factor of f of x. So first we want to take that factor, the x minus 5, and what value would make that equal to 0 is x equals 5. That means that 5 is actually one of our solutions. I'm going to go ahead and put that in the box. I say 5, comma. Now because this is an x cubed, remember we can have at most 3 solutions. But we want to take that x equals 5 and then do synthetic division with this, with that polynomial. So I'm going to write x equals 5, and my coefficients are a 16 for the x squared, a negative 64 for the x squared, or sorry, a 16 for the x cubed, a negative 64 for the x squared, a negative 77 for the x term, and then a negative 15 for my x term. Now because this is a factor, because x minus 5 is a factor, this should give me a 0. Should give me a 0. If it doesn't, we've done something wrong there. So I'll bring my 16 down. 5 times 16 is 80. I'm going to add negative 64 plus 80. That will be a 16. 5 multiplied by 80, or by 16, again, is going to be 80. Negative 77 plus 80 is 3. 5 times 3 is positive 15. Negative 15 and positive 15 is 0. That's fantastic. That means we did this correctly. So what that means is that 16 x cubed minus 64 x squared minus 77 x minus 15 equals, parentheses, x minus 5, that was the factor we knew. And then another set of parentheses, 16x squared plus 16x plus 3, and there's a remainder of 0, so we don't have to worry about that. So finally, we want to either try to factor 16x squared plus 16x plus 3, or use the quadratic formula. So that's going to give us the other 2 solutions. So let's see, 16 times 3 is 48. Can I find 2 factors of 48 that add to be 16? Yes, actually 12 and 4. So I'm going to factor this. This will be 16x squared plus 4x plus 12x plus 3. Now my first 2 terms have a 4x in common. So that factors as 4x times 4x plus 1. And the second 2 have a 3 in common, 12x and 3. So plus 3, parentheses, that'd be 4x plus 1. So that this factors finally as 4x plus 1 and 4x plus 3. Now, if my process of factoring doesn't quite set well with you, I might want to go back to EQ2, okay, and look over that. So my original polynomial factored as x minus 5, one quantity, 4x plus 3, that's another quantity, and 4x plus 3, that's a third quantity. So setting each one of those equal to 0, we see that x minus 5 will equal 0 when x equals 5. 4x plus 1 will equal 0 when x is negative 1/4. And 4x plus 3 will equal 0 when x is negative 3/4. So those are the 3 things I'll put in my box. I already have 5, comma, negative 1/4, comma, negative 3/4. And we've just found the 3 real zeros of that cubic function we had, that polynomial. Our next objective is PR6. Graph polynomials based on end behavior zeros, and multiplicities. So question 6 says, find the zeros, x-intercepts, the y-intercept, end behavior algebraically, not graphically. Use this information to choose the graph of the following functions given that x is a 0, or the x equals 4 is a 0. So my function is f of x equals x cubed minus 9x squared plus 24x minus 16. I know it's a cubic, and in fact, for end behavior, this is going to be an odd positive. As a positive leading coefficient, and the x cubed is the highest exponent. That's an odd number. So odd and positive will fall to the left and rise to the right. So we know that our graph that we choose should fall to the left and rise to the right. Now next we can take that function x squared minus 9x squared plus 24x minus 16 and try to find the x-intercepts and the y-intercept. So the x-intercepts, I'll set that equal to 0. It'd be great if that factored, but I'm not sure that it's going to. No, not great. Okay, so let's first take and note that 4 is a 0, so I can do synthetic division with 4. For my x-intercepts, I'm going to take my coefficients of 1, negative 9, 24, and negative 16, and do synthetic division with x equals 4, because that is the known 0. So bring down my 1, so 4 times, so we have 1, 4 times 1 is 4, negative 9 plus 4 is negative 5, 4 times negative 5 is negative 20, 24 plus a negative 20 is 4, 4 times 4 is 16, negative 16, and 16 is 0. So I have x minus 4 is how this will factor. X minus 4, and then I have x squared minus 5x plus 4 from the values on the bottom row of that. I had a 1, negative 5, 4, and a remainder of 0. That becomes x squared minus 5x plus 4. Now x squared minus 5x plus 4 also factors as x minus 1 times x minus 4. So this ends up as x minus 4 parentheses, x minus 1 parentheses, x minus 4 parentheses. 3 different quantities. So that means our x-intercepts, our zeros, are 4 and 1. With an m, or multiplicity, 4 is a multiplicity of 2, and 1 is a multiplicity of 1, based on the number of times those factors show up. All right, so this function should cross, because we have an odd multiplicity for 1, that one should cross, and because we have an even multiplicity on the 4, that one should touch and turn. Turn around is the way we said that usually. So it touches and turns around at 4, and it crosses at 1. Now, let's go ahead and find the y-intercept. The y-intercept would be finding f of 0. So my function was x cubed minus 9x squared plus 24x minus 16, so I'm going to evaluate that at 0. That would be 0 cubed minus 9 times 0 squared plus 24 times 0 minus 16. And putting that into a calculator or something else, that should be negative 16. So we have a y-intercept of 0, negative 16. Now those are all the things we were told to find, so let's compare to our graphs. The first graph falls to the left, rises to the right. That matches our end behavior, so I'm not going to remove that one yet. Put a question mark there. The second graph falls to the left and rises to the right, so I'm going to keep that one as well. The third one, same thing. It falls to the left, rises to the right. We'll keep that one. But the last graph rises to the left, falls to the right, so that graph is out. Next, we might look at our x-intercepts. So the first graph has an x-intercept of negative 4 and an x-intercept of 1. Well, our x-intercept should be 4 and 1, so that one cannot match. First graph's out. Our second graph has two x-intercepts. One of them is -1, and the other one is 4. That again does not match. That graph is out. So the next graph crosses the x-axis at 1, touches and turns around at 4. That matches our x-intercepts. And its y-intercept is below the x-axis. Below the x-axis. It's down past -5, so -16 could be possible. So that is in fact the graph we would select. That's the graph we would select, because it matches those characteristics. Now, the work for this includes finding the end behavior, the y-intercept, the x-intercept. Unless for some reason you think, aside from using a graphing calculator, you could justify your choice with fewer than that, all that information, in which case, be prepared to justify yourself. Why you think only the x-intercepts or why you think only the end behavior will help you determine the right graph. So, there's PR6, graph a polynomial based on end behavior, zeros, and multiplicities. All right, now for PR7, this question, or this objective, is determine the characteristics, vertical asymptotes, removable discontinuities, horizontal or slant asymptotes, domain, and zeros, and graph rational functions. Now this question, or this objective, has two questions that go with it. So, question 7 says f of x is a rational function given in both standard and factored form. So let f of x equal numerator 3x plus 8 over denominator 8x squared minus 6x minus 17, or minus 27 that is. 8x squared minus 6x minus 27. And that also equals in factored form, numerator 3x plus 8. Denominator is 4x minus 9 quantity times 2x plus 3 quantity. And we're told to find the domain in interval notation, the y-intercept, the x-intercepts, or intercept, vertical asymptote, and horizontal asymptote. All right, now, from our notes, we know that finding the domain is based off of the denominator. So let's take the denominator in factored form and set those equal to 0. So over here, I'm going to find my domain, and that's going to be 4x minus 9 equals 0. Well, 4x minus 9 cannot equal 0, and 2x plus 3 cannot equal 0. So solving those two, we see that x cannot equal 9 over 4, and x cannot equal negative 3 over 2. So my domain, in interval notation, will begin at minus infinity, so parentheses minus infinity. I'm going to choose all of my negative numbers except for negative 3 over 2. So this interval will go up to negative 3 over 2. Negative infinity, comma, negative 3 over 2, parentheses, union, parentheses, negative 3 over 2, comma, all the way up to 9/4, close parentheses, union, open parentheses, 9 over 4 to infinity. So we've taken every real number except for those two. Now this also tells us the vertical asymptotes, okay, because we don't have any common factors that would actually reduce. The vertical asymptotes are x equals 9 over 4, comma, negative 3 over 2. Now the y-intercept will be found, just like in polynomials, finding f of 0. This is my y-intercept, f of 0. I'm going to use the standard form, so that'll be 3 times 0 plus 8 as a numerator, all over 8 times 0 squared minus 6 times 0 minus 27. The numerator will be 8, the denominator will be negative 27, and that doesn't reduce. So the point for that is 0, negative 8 over 27. Fill that in as part 2. 0, comma, negative 8 over 27. Now, x-intercepts are based off of the numerator. Where is the numerator equal to 0? Or what value would make the numerator equal to 0? So I'm going to take the 3x plus 8 and set that equal to 0. Solving that, we see that x is equal to negative 8 over 3. So that means my x-intercept is the point negative 8 over 3, comma, 0. Put that in part 3. Negative 8 over 3, comma, 0. That is my x-intercept, and the only x-intercept I have. If you had other factors, you might have more. But. All right, now, finally, the horizontal asymptote. Well, because the degree of my numerator is 1, it's a linear polynomial, and my denominator is an x squared, that's a quadratic, the degree is higher in the denominator, so we know from our rules that this would be y equals 0 as my horizontal asymptote. All right, so we just had to find all these characteristics based off of that radical or rational function. Now, the last question we have says, select the choice that is a graph of the function f of x equals, my numerator is x plus 2 quantity times x minus 1 quantity. My denominator is x plus 1 quantity times x minus 3 quantity. Now, this has everything we need to know because we can first find our x-intercepts. X-intercepts come from the numerator. Okay, so I'm going to take x plus 2 equals 0 and x minus 1 equals 0. And solving each one of those, I see that x equals negative 2 and x equals positive 1. So I should have x-intercepts of negative 2 and 1. Now, my first graph has an x-intercept of negative 1 and an x-intercept of 2. Those signs don't match, so my first upper left function is out. My next function in the upper right has an x-intercept of negative 1 and an x-intercept of 2. That does not match either. My x-intercepts are negative 2 and 1. The bottom left function has an x-intercept of negative 2, an x-intercept of 1. That matches. I'm going to leave that function. And then the bottom right that I have has an x-intercept of negative 2 and an x-intercept of 1. All right, the next thing I might do is look for vertical asymptotes. Now, vertical asymptotes and domain both come from the denominator, right? I want to set the factors in the denominator not equal to 0. So x plus 1 is not equal to 0, and x minus 3 is not equal to 0. Solving each one of those, see that x is not equal to negative 1 or positive 3. And it appears that both of those have vertical asymptotes at negative 1 and 3. That doesn't help. Let's next find our y-intercept. Y-intercept will be finding f of 0. So in my function, I'm going to have in my numerator 0 plus 2 quantity multiplied by 0 minus 1 quantity. My denominator is x plus 1, so it'll be 0 plus 1 quantity multiplied by 0 minus 3 quantity. My numerator will be 2 times a negative 1, so that's negative 2. Denominator will be 1 times negative 3, that is a negative 3. So that my y-intercept is positive 2/3. F of 0 is that, so that's 0, 2/3. Now, of those two lower functions, only one of them has a positive y-intercept, and that is the bottom left function. Now, the work that I've done for both of these questions, of course, needs to be placed where the add work is. All right, but now we can take those characteristics, we can find certain characteristics, and that narrows down our choices for our graphs. All right, hopefully this helps you review for PR1 through PR7, your objective check. Good luck.